So good afternoon to everyone. So this is my work using electrochemical noise method to assess conventional corrosion inhibitors and green inhibitors in different environments. And this work was done in the University of Nottingham, and as a 6 months short-term research. And I was under the supervision of Professor Eleanor Binner, and Dr. Douglas Mills also helped me a lot in the electrochemical noise field. So here's the content. I will give you some brief background information and the candidates, inhibitors, and how this experiment was done. And then I'll show you some results and analysis and conclusion further work, also the acknowledgement. So here's the background information of why this inhibitor work was doing. So the corrosion inhibitor are very popular especially in oil and gas company for their production and the transport process. However, most of the corrosion inhibitors currently used are toxic and harmful to the environment. So this work was going to test those green inhibitors which can be extracted from green plants and compare with the traditional inhibitors. And in this work, I have used broccoli and sugar beet. The reason why I chose these two plants because the broccoli showed good results in the previous work, which it was done by the previous students, Mark and Joshua, and they showed good results in HCl solution. And the sugar beet was just available in powder form in the laboratory, so I just picked it up. And it's important to mention that we need a quick method to assess those inhibitors. And the electrochemical noise measurement has the potential for this application. However, we need to prove this method is actually working for this particular research. Then I will show you later. So here's the brief introduction for the electrochemical noise. From the picture here, this blue box called prochrometer, it was designed from the DCVG company, and it can gather in those current and voltage data during the experiment. Here we used a electromagnetic stirring, and from my previous experiments, it helps to get better results. But this piece of equipment was designed for the high impedance system, but is good enough to get information for the bare metal. So it's a quick introduction for this software and how I done this. And as I said, all the voltage and the current signal are recorded at the same time when you're doing the experiment. And in this particular experiment, I have used 1080 data points, and you can set how many points per second. In here is 5 points per second, and for the whole run, it takes 6 minutes. And the whole set of this experiment takes 3 hours, and that's 10 runs for each specimen. And all the data has to be downloaded to the computer and use this software to analyze all those data. And as you can see, you can get those plots, voltage versus time, and the current versus time. After that, this software can calculate the resistance value. And first of all, if you get those results, it's the first thing to inspect those plots whether they are good or not, and this may indicate the further analysis and brush detrend function. Here's some details for this experiment. Here is a sample holder which made by ABS material by 3D printing. And those blacks, those small specimens are low carbon steel and covered with the black zippy coating. And this coating is a very good quality coating with good edge recovery and durable protection, which enable you can reuse those specimens after each test. So here is the broccoli. I used the traditional way to to get the extraction, which means cook it. So I have done pretty much the same stuff, same experiment for the sugar beet. Here is the environment for the testing. I've used the 1% propagyl alcohol in 3 different concentrations of HCl solution and compare with no inhibitor. And I've used 2 concentrations of inhibitor, 1 and 2, because I have to, the confidential agreement. So I just mention it as inhibitor 1 and 2. In 3% sodium chloride and saturated CO2 environment, and compare with no inhibitor. And I have used 2.5 sugar beet and 50% broccoli in those 2 environments, compare with no inhibitor. So before I show you some results of this work, I would like to mention the mass loss. To calculate mass loss, I didn't use the traditional way, like weighing the specimen before and after the experiment, because it is inaccuracy. Because those blanking of compound can be gain and lose weight because absorbing and deabsorbing the solution. So this mass loss work was done by the ICP test, and which means it can calculate the ion concentration dissolved in the solution. And it is important to dissolve those iron oxide or the corrosion product in the solution, which it is easier in the HCl solution, but you need to add a little bit more acid in a CO2 environment. So at the end of the experiment, all the sum of the solution, or like 50 milliliter, were collected, then sent to the ICP analysis. Then you can have the concentration of the iron content in the solution, and with the known value volume of the whole solution, you can calculate the mass loss for this particular experiment. So here is the results obtained in HCl solution with and without propagyl alcohol. As you can see, the top 3, they are in the 3 different concentration of HCl, but with 1% propagyl alcohol. It got a higher Rn value, which means the propagyl alcohol did some protection for the iron samples. And at the bottom 3, they are just a pure HCl solution. And the top one, which means that's got highest Rn value, as a 5.5 HCl solution with 1% propagyl alcohol. It got a better protection. To compare with this work and with the Rn and the calculated mass loss and the measured mass loss by the ICP test, here is the equation. I've used the Faraday law. Here you maybe notice that the Rn value was divided by 4 because in the previous experiment I mistakenly input 400 millimeter square as the cell area. But this software, it did the calculation itself. So to correct this mistake, I'll divide those Rn value by 4. And here I got two different B value. So it depends on the BA and the BC using the Tafel equation. And the BA and BC were 60 in the acid solution, and the B equals 0.013. And the BA and the BC were 120 millivolts in the inhibitor acid. So the B number is here. We can use those parameters in this equation. We can get the mass loss calculated from the Rn value, this column, and I got the mass loss from the SCP test from here. Then I calculated the ratio, and to compare this method and to compare the mass loss and to determine this method is working or not. And you can see those ratio are quite near to 1, which means this method are reasonable good. However, only the second one got some problem with it. So here's a short conclusion. The propyl alcohol provided a significant corrosion protection, especially for higher concentration of HCl solution. And the Rn value of 2.6 HCl solution without inhibitor was a bit unexpected, but it showed, I'll go back, it showed some like reasonable information. It got the lowest mass loss in these 3 sets, and it also got the lowest mass loss from the calculation, and it got the highest Rn value. So it could be some problem in the experiment, but it showed the reasonable results. So here's another set of the experiments, and the results was obtained from conventional inhibitor and the green inhibitors. As you can see, almost all the results they were increasing over time, but apart from this one was the broccoli. But I think I added too much broccoli solution in the experiment. Anyway, that's the expression. For the sugar bit, it surprisingly got the highest Rn value and got the biggest increase over time. And for the 2 conventional inhibitor, it didn't do well in this particular experiment. And I was guessing it probably designed for the higher concentration, for the higher temperature and the higher pressure environment, not for room temperature. So I increased the temperature to 50 for these 2 inhibitors, and the blue one was obtained at room temperature, and the red one was in 50. And you can see for the 2 inhibitor, it didn't change much compared with the room temperature and in 50 degree. However, you can find the inhibitor 1 did better than inhibitor 2 for both cases, and the more concentrated solution did better than the lower concentration. So here's the short conclusion, just like it's like a repeat things. The Rn value was increased over time, probably because the carbonate film was forming during the experiment, and the inhibitor 1 did better than inhibitor 2. Higher concentration did better than the lower concentration, like 100 ppm level. And the sugar bit did well and got the highest Rn value and the biggest increase over time. And there's a not big difference between the 2 temperature. So here's the conclusion. The sugar beet got more potential in this work than broccoli. And from the calculated mass loss and the measured from ICP experiment, ICP analysis, so it proved that the electrochemical noise measurement is a reliable and quick method to assess corrosion process. And it also shows the ICP test is easier and quicker method to compare to the traditional weight loss experiment. And that's a good correlation between the calculated from the Tianyan results and the calculated and the measured mass loss results. So here's the further work. As a more testing for broccoli and the sugar beet solution in 3% sodium chloride and saturated CO2 environment in room temperature and 50 to see whether we can repeat to get those promising results. And also probably do a comparison experiment for electrochemical noise for the RN and ICP analysis and the traditional weight loss. However, because in the oil and gas industry area, those inhibitors are special designed for high temperature and also with the pressure environment. So in here, we need to develop this method can be used in higher temperature and higher pressure environment. So for this particular work, I would like to thank the University of Nottingham for providing the laboratory and the facility, especially those three people helped me, and for Stephen and Jason for the 3D printing work, and Vicky did the ICP test for me. And thanks for Philip Wilkinson for the blanking off compound, and especially for the DCVG company, Simon Young and Sarah Leeds, for provide this equipment and the technical support. And thanks Josh for design this sample holder, and the Clarent Oil Service for the 2 inhibitors. Yeah, that's pretty much.
Hey, thank you, Tianyan. It's really interesting to see that the policy of 5 fruit and veg has now gone into the coatings industry. So, open for questions.
Hello. Thank you for your presentation.
Yeah.
There's just a quick question about because it's a plant-based. Is there any?
You mean this?
Yeah. Is there any requirement for purification process from extraction? Because from the plant-based may produce a lot of chemicals in that. Yeah. Is there any process after this to get like a major key active ingredient to prevent the corrosion to occur?
Sorry, can you repeat it again?
Okay.
Sorry.
Sorry about that. So basically, from plant-based, is there any required to further purification to get a major key active ingredient for corrosion inhibitor?
Are you talking about the broccoli?
Yes, broccoli and beetroot.
For the particular green inhibitor, because Vicky in the University of Nottingham, she worried about the particles, the small particles goes into the ICP tubes. So, and this ICP test was mainly to prove this work is applicable. And so I didn't use the broccoli, also the sugar beet solution. So, sorry.
Okay, I think the question was, did you purify to try and find out if there was an individual chemical component in the broccoli which was causing the inhibition?
The answer is no, because this is quite a short period for the inhibitor work, and also you need to study if you want to dig deeper for the broccoli, and you need to learn or analysis the element in the broccoli extraction. And actually, I got too many testing needs to do, and this work, like using electrochemical noise method to prove all those results are reasonable to get.
Any other questions?
Yeah, there's a question from the secret audience. Over the last 10 years, there have been many publications studying potential corrosion inhibitors from natural products. Do you know of cases where such a corrosion inhibitor has been successfully commercialized? And if not, should we carry on looking at these materials, or is it something of a interesting but technically dead end?
Yeah, I've saw many people doing those kind of research using the natural plants, or even some waste from daily work. I hope this research can be used for commercial, which means that we can save a lot of money and resources to get those inhibitors for like coatings for oil transport service. But I don't know why they don't like develop those. And from the paper, it quite like what I got. It's reasonable. Those inhibitors are reasonable, good, but there should be some technical barrier.
Okay, I've just got one point actually, is that the obvious natural ingredient coming out of sugar beet is sugar, sucrose. So you could check to see whether sucrose works as a corrosion inhibitor. Sucrose.
Yeah.
The chemical compound sucrose is sugar. Get some sugar, put it into a mixture, this would inhibit.
Yeah.
Okay, one question.
I'm not familiar with the DCVG device.
Yeah.
I would always recommend that if anyone wants to do electrochemical noise measurements, they validate their equipment before they do the measurements, because it's very easy to measure the wrong thing.
Yeah.
Have you done that?
Yeah, I've used it for a few years.
But have you validated it according to the procedures?
Yeah. Before this experiment, I was using this electrochemical noise, like the prochrometer, for my master study in Northampton University. I've compared with the RM value obtained from the electrochemical noise with the EIS, the electrochemical impedance spectroscopy, and that's got a good correlation with those two values.
They also provide a box, which may be what Bob's on about.
The box.
Testing the equipment.
The box.
Well, no, there is a particular paper that a group of us prepared, which tells you what you should do to make sure you are measuring your system, not your instrument. It's very easy to get data from the system that is basically instrumental noise.
Yeah.
Especially in your sort of situation where you're dealing with very low values. I do have one other question. That is, you quoted your RN values in ohms.
Yeah.
Ohms per what?
Ohms per 100 milliliter square.
Because we would normally measure it to ohm centimeters squared, normalize it, so we don't have to think about what your area is all the time. Okay.
Yeah, probably I'll let them know to update this software. Yeah.